Good morning, grade 11s. Welcome to Tuesday, April the 28th. Hope you had a good day yesterday, and hopefully some of the reading made sense for you yesterday. I know the one part that might be the most confusing was the concept of standing waves and nodal points, and I'm still working on rigging up something where I can show you a standing wave, and hopefully I'll be able to do that tomorrow. And thereby we'll just do a little bit more explanation on that tomorrow. As we get started today, I want to again share with you a verse of the day, and today's verse of the day comes from Deuteronomy chapter 6 verse 5, where it says, "Love the Lord your God with all your heart, with all your soul, and with all your strength." So I want to encourage you today to find ways in which you can love God and then love others as well. And so as we go on today, what we want to talk about today is again 4 more wave properties. And these are wave properties that deal with waves that are more two-dimensional, where they have a component that is up and down and left to right, like a water wave. Water waves are the easiest way to picture these, and so we'll be looking at that a little bit. And the 4 properties are quite simple, and we're just going to go through these today. Again, these are covered in your textbook, so I will include a short, just 2-page reading that goes along with this lesson. And then tomorrow, hopefully we'll be able to go over the standing waves concept, and then I've got a few more questions at the end of this chapter. Before we move on to some specific types of waves, we're going to be looking at sound waves and light waves more specifically, and these properties will come back in those units as we talk about those waves, and we'll develop some of the formulas and some things that go along with that as well. So the 4 properties that we want to talk about today are, first of all, something called rectilinear propagation. And that's just a really big fancy word for straight line motion, and basically the property is that waves travel in straight lines. So unless there's a barrier, or unless there's something that it reflects or some of the other properties off of, then waves will always travel in a straight line. And so linear is in here for straight, propagation is a movement, and so we have straight line movement. The second property that waves all hold to is the property of reflection. And the property there is that if we have a wave that is coming in to a barrier, it will get reflected off that barrier. And the property that has to hold is that the angle between this vertical line, called the normal line. Remember, we talked about normal force when we did dynamics, the force that was perpendicular to the surface. This is a normal line, which again is perpendicular to our surface, to the barrier. The angle between the normal line and the incoming ray, theta I for incoming, has to equal the reflected angle, theta R. And again, if you've ever played pool or billiards, you know that property holds too. When you bounce a ball off of the bumper on a pool table, the incoming angle will equal the reflected angle. And you can see all sorts of things when you bounce a ball off the floor or off the wall. Same property holds. Waves follow that property as well. The other 2 properties are on the other board. Let's go take a look. The third property that we want to look at today is refraction. And refraction is the bending of waves as they move from one medium to another medium. In yesterday's video, we talked about when it traveled from a fast medium to a slow moving medium at the barrier there was a bit of a reflection, whether it's free end or fixed end. Today we're looking at waves like maybe a sound wave that goes from air into water, or a light ray, a light wave that travels from air into water. There is a bending that happens. And so if we have a ray that's coming in here, there's a bending. Now the amount of bending is based on a law. It's called Snell's law. And when we get into a unit later on, where we're going to look at refraction specifically in lenses, we will look at Snell's law, and we will use Snell's law to determine how much bending is happening. So for now, all you need to know is that refraction is the bending of a wave as it moves from one medium to another. The final property that we want to look at is diffraction. Diffraction is the bending of waves as they pass by or through a barrier. And here I'm going to draw some diagrams. So I've got 3 separate diagrams here. Here's just a single barrier, here's 2 barriers, and here's 3 barriers. And what I'm going to do is, hopefully this will make sense, I'm going to start by drawing waves. So here's this is a top-down view of a water wave. So here's a crest of a water wave. Okay, and then the next crest, and the next crest. Okay, so these waves are moving in this direction towards the barrier. As they hit the barrier, what happens is they start bending, and they do this kind of thing. Okay, so these waves over here are continuing in a straight line. These waves are also in a straight line, but they have bent in this direction. Still straight line motion, because of property 1, waves travel in straight lines, but now they have bent and they are moving out in that direction. If you were here, I have a little wave table that I could use, and we could see this, we could observe this, but unfortunately we don't have that, but you'll have to trust me that this is what happens. Now, when we go between a barrier here, we're going to do the same thing. We're going to have some wave crests heading toward these barriers. As it hits the barrier, what happens is, again, it bends, but now it bends in both directions. And so now, waves are going, it becomes a circular wave front. Like when you drop a stone in a pond and you get the circular wavefront that goes out from it, that's what happens on the other side of the barrier here. And again, every point on these waves is traveling in a straight line. Okay, so you can have a circular wavefront where every part is still traveling in a straight line, so it doesn't mess with the other property of rectilinear propagation, even though it is a curved wave front. And finally, what happens when we have a wave that hits 3 barriers where there's 2 openings? So again, we're going to have waves that are traveling in this direction, and we'll hit those 2 openings. And again, it's the same thing. Each opening will have this happen. So we'll have a circular wavefront happening here, and we'll have a circular wavefront happening here. Okay, and again, they have these things heading out in their straight lines. Okay, heading out, and so forth. I'll put one here and one here. And what we get here now is you can see some areas here where when we have this interaction, this gets into what we talked to yesterday about the superposition principle and the constructive and destructive interference, right? We have interference here. At a variety of points here, we have crests meeting troughs, right? So if we look here, if I could open this marker, there we go. Right here, we would have a crest meeting a trough, and that would become a nodal point. Okay, same here. Okay, and a bunch of, and if we continued these out, we'd have more and more of them. And what you'd actually find is that these would actually line up in nice lines where you would be able to you'd be able to see what are called nodal lines. Okay, they form nice lines out from this point. But for now, because we can't draw it all out, I think. No, I thought maybe there was a picture in your textbook, but there isn't. I'll try to find a picture for you where you can see the nodal lines better than what I can draw. But this is what happens. Basically, these 2 are the main ones, okay, where we go past a barrier, where we go through an opening. Here, when we go through 2 openings, we just have this scenario happening, but we have it happening in both openings, and this will create an interference pattern where we will have nodal points. Remember that nodal points are points of complete destructive interference where a crest meets a trough. All right, that's it for today. That's all I wanted to share with you. You're going to have a short reading, page 390 and 391 out of your textbook. Again, you can find those page numbers on Connect, or you can just listen to what I said. And we will look again more at standing waves tomorrow, and as well as a short assignment tomorrow. Hope you have a great day, and we'll see you tomorrow.